All right, so today we're going to look at section 3.4, and there's really two kind of ideas in the section. The first one we're going to look at is what's called rational zeros. And I'm going to show you a way that you can find all the rational roots of a function. And then the second thing we'll look at is synthetic division. All right, so when you're solving an equation and finding the roots, functions can have both rational and irrational zeros. What does it mean if a number is rational? Remember? Yeah, Leo?
It's a real number.
Well, irrational is also a real number. Rational and irrational together make up the whole set of real numbers. But does anybody remember what it means for something to be rational? It means it can be written how? Yep.
Isn't it like, doesn't it have a distinct end?
It could repeat forever. For example, 1/3 is a rational number, even though there's no end to it, and it repeats forever. But the point is, a rational number can be written as a
Fraction.
A fraction. Yep. So there's a theorem that you can use. And this theorem, what it does is it generates a list of possibilities. Okay? It doesn't necessarily give you an exact answer. Okay? That's how I want you to think of this theorem. It generates a list of options to pick from. And if there is an answer, it's going to be in this list of options. Okay? We still have to investigate with the calculator to see a little more detail, but this at least gives you kind of a starting point. All right, so suppose you have some polynomial written in descending order. Like 3x to the 5th plus 2x squared minus 8x plus 7. Okay, something like that. Highest to lowest exponent. Okay, so what this says, I know it looks like just a bunch of crazy symbols, but it says for all values of n, every coefficient is a rational number. That's what it says. So what we're assuming in this problem is that all the coefficients of your x terms, the first one, the second one, the third one, the fourth one, the fifth one, the sixth one, all of them, that's what that symbol means. All a sub n's have to be rational numbers. And two things we're going to assume. The first coefficient and the constant at the end cannot equal 0. This theorem doesn't work if they do. So the first coefficient and the constant at the end cannot equal 0. Other than that, the coefficients just have to be rational. Okay? That's what that says. So, if there is a rational root, or if there's a place where this graph crosses the x-axis and you can write that location as a fraction, it can be written just like this, p over q. And there's a criteria for what p has to be and for what q has to be, and it comes from what's up above. So p has to be a factor of the constant. So p is a factor of the constant. And q is also a factor, but it has to be a factor of the leading coefficient. So if there's a rational root to a polynomial, fitting the characteristics I described right here, then it's going to be of the form p over q, where p is a factor of the constant, q is a factor of the leading coefficient. So, as I said, when you generate this list of possibilities, that's all that it is. It's a list of possible options. Not every single option you generate is going to work. So once you generate this list of possible options, then you've got to investigate it a little further and see, okay, I have a bunch of options, which ones actually work? So the rational root theorem only gives you a starting point. That's all that it does. Okay, so what we're going to do in this one is make a list of possibilities. I want to make a list of what the rational roots could be. Right, so after we make a list of options, then we'll use the calculator to help us narrow down which one of those options actually work. All right, so let's start by identifying P and Q for this problem. So P are all the factors of the constant. Shauna, what's the constant here? -6 or 6, they would both have the same factors. And what are the factors of 6?
1 and 6, 2 and 3.
So 1, 2, 3, 6. Anything else? That's half of them. Yeah?
-1, -2, -3,
Yeah. Those are all the numbers that divide into 6 without remainder. So in this problem, P could be plus or minus 1, 2, 3, 6. Now Q is all the factors of the leading coefficient. What are all the factors of 10, Leo?
1, 2, 5, and 10. And then all of them as negatives.
Yep, so plus or minus 1, 2, 5, 10. And now, if there is a rational root to this problem, it's going to be of the form P divided by Q. We have to write out all the different combinations you could have. So we try to make a list and do it systematically. So I'm going to start with the first value for P and divide that by every value in Q. So I could have 1 over 1. I could have 1 over 2. I could have 1 over 5. And I could have 1 over 10. Again, these aren't all roots. It's just a list of places you're going to graph and we're going to investigate and narrow it down. Okay. How about the next one, if I do 2? Okay. What would be my first root starting with using 2 for P and then using all the Q's? Sam?
Plus or minus 2.
Plus or minus 2? Yep. And what would the next one be?
Plus or minus 1.
Yep, it would be plus or minus 2 over 2, but we already have that one from before, so we don't need to write it again. The next one?
Plus or minus 2 over 5.
Yep, plus or minus 2/5. And?
And then we already had the next one, which is plus, or positive, or just say it like, the 1 over 5.
Yeah, so 2/10, we already have that one as 1/5, so we don't need to write that one again either. Okay, so the next one, now we're going to do 3 over all the different options. So we get plus or minus 3. What would be next? About Abby? Yep, we don't have 3 over 2. Yep, next one. Be
3/5.
3/5, and the last one?
3/10.
3/10, perfect. 3/5. 3/10. And the last one, 6 over all the different options. So we could have 6. How about 6 over 2? Do I need to write that one? No, we already have 6 over 2, that's 3. 6 over 5, do we have that one? No, we don't have 6 over 5. And the last one, 6 over 10, do we have that? Yep, that's 3/5. So what we just generated is a list of all possible rational roots. That's all it is. It's a list of possibilities. So if there is a rational root to this problem, I guarantee you it has to be one of these numbers. Has to be. Okay. Any questions on that? So now what I do is use the calculator, and I'm going to look in those areas and see, does it look like it's crossing the x-axis anywhere near those numbers? And we'll eliminate the ones that don't seem to make sense. So I'm going to type it in. 10x to the 5th minus 3x squared. All right, so 10x to the 5th minus 3x squared plus x minus 6. And this gives me a good idea of what my window should be. What's the largest x value in that list? Yep.
Positive 6.
And the smallest?
Negative 6.
-6. So you can set your x min and x max to -6 and 6. If there's a rational root to this problem, it's not going to be beyond those two numbers. It has to be one of them. Okay. So let's go. I'm just going to go -8 to 8. I should probably set my y min like -10 to 10. In fact, I'm just going to stop it and do that first. Let's try -10 to 10. Okay, so it looks like it just crosses in one spot. And I would say a lot of these I can eliminate right away. Out of all the roots that we listed as possibilities, is there anyone here that stands out that it looks like it could be? Yeah?
Could be or
Could be.
plus 1.
Yeah, I would agree with +1. That's a good candidate that it could be. I wouldn't say a half, a fifth, or a tenth. 2/5, no. 3, 1.5, not really. 3/5 is 0.6. It's not really that close to 0.6. 3/10, no. 6. 6/5. Could that be a candidate? I mean, if you take 6 and divide by 5, it's only just a little bit past 1.2. I mean, if you put that as a candidate, I wouldn't mark it wrong. I would say the only two ones that are even remotely reasonable are the two that I circled in red. So on the test, this kind of question is usually in 3 parts. 1, generate a list of all possibilities. That's what's in black. Step 2, just circle the ones that seem reasonable. Okay? I would say the only ones that seem reasonable or even close are the ones in red. And then step 3 is to actually confirm which one works. All right? And the way you can confirm which one works is you can go second calc root, or you can just trace to the point. And we can see that when x is 1, it's not a root. So 1 actually is not. And if I try 6/5, that's not either. At 1.2, I'm up at 15. So even though these two numbers, especially +1, looked reasonable, it's not a root. So what does that mean about where that graph crosses the x-axis? It's not in this list. So what kind of number must it be where it crosses?
An imaginary number?
If it's imaginary, we wouldn't see it cross. But you're thinking along the right ideas. Yeah?
It's not a rational number.
It's not rational, so it must be
Irrational.
irrational. So the only root, and I think that's going to be the next question we look at. This graph crosses the x-axis in one spot. It's not in the list of possible rational answers, so that has to be irrational. There's no other explanation for it. So now that we just answered this question, it says show that the graph we just had has one real root. Okay. by graphing it, we've shown that it has one real root, and prove that it's irrational. Okay? To prove it's irrational, just write down what we just said. Okay, so here's our graph. All right, so for the first part, show that it has one real root. Okay, there's the graph. So the graph shows we have one real root. The next thing I would say is, after checking the two numbers that we thought were reasonable, 1 and -1. So after checking, what was it, 1 and 6/5? 1 and 6/5. And I'm just going to put in parentheses, those were the reasonable answers after looking at the list and looking at the graph. Okay, so after checking the reasonable answers, neither one of them was a root. Neither one was a root. And if that number right here is something other than all the numbers in the list we just had, then it has to be irrational. Okay? Because we wrote down every rational one, and they didn't work. So since the root is not in the list of rationals, it must be irrational. Maybe you could shorten that up a little. I'm not really sure how much you could shorten it, but the graph shows you have one real root, and the numbers you checked in your list of rationals don't work, so the number has to be irrational. That's it. That's how you show that. So any questions on that? Okay, we're going to do some today that actually work. Okay, so it's kind of, I don't know, it feels kind of like lousy when you generate this whole list of numbers, and after all that work, none of the numbers even work. All right, but sometimes that happens. So is there any question on what I mean by generating a list of all possibilities and then narrowing that list down to some actual candidates that seem reasonable, and then actually finding out if they really work? Yep.
So like on a test or something, would they be like simple problems like this that don't have a gigantic list of factors?
Yeah, I mean, this is probably about as big as you would get. I mean, here you've got quite a few. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 24 possibilities. That's probably the most we would have. You won't have like in the hundreds. No. In fact, a lot of problems have a lot less than that. Okay, so any questions on the rational root theorem? We'll do more with it later on, but that's basically it. That's the idea of the rational root theorem. All right, so the next thing I'm going to show you is synthetic division. Okay, it's another way you can divide polynomials, but only if you're dividing by something linear. X minus a number. It could be x plus a number. But it has to just be an x plus or minus, and then just a number. Okay. This algorithm is also called Horner's algorithm, H-O-R-N-E-R. So if you see in your book, solve the following problem using Horner's algorithm, that just means use synthetic division. Okay, but that's just what your book calls it. All right, so I think like we did yesterday, I'll do a problem as we're going through the steps. All right, so first thing is write down all the coefficients of f of x, fill in zeros for any powers that you're missing. All right, so what I'm basically doing in this problem is this. That's when it says to show that 3/2 is a root, what I'm going to do is use what we learned yesterday. If 3/2 is a root, x minus 3/2 is a factor. So I'm going to divide by x minus 3/2. And if I get a remainder of what, then it proves x minus 3/2 is a factor. What do I have to get a remainder of? Yep.
0.
0. So if I divide by x minus 3/2 and I get a remainder of 0, that proves x minus 3/2 is a factor, which also proves 3/2 is a root. It also proves it's an x-intercept and all that stuff. Okay, so that's basically what we're doing. So you put the number after the minus sign, and that's the key. The number after the minus sign on the outside of your bracket. Now I need some space. Write down all my coefficients. Am I missing any coefficients from cubed all the way down to my constant? No. So I'm going to put 2, -5, 1, 3. So bring down the first coefficient, 2. We're going to multiply the divisor, 3/2, by the coefficient I just brought down. Okay, what's 3/2 times 2? Yeah, Leo?
6/4. No. 6 over 2.
6 over 2, which is?
3.
3. So multiply the divisor, what I circled, by the first coefficient, the other thing I circled. So Leah just did that, and we get 3. And write the result below the second coefficient. Okay, I did that. Add the number I just wrote and the one that's above it. What's -5 plus 3? Dylan?
-2.
Yep, -2. And now repeat until we're done. Okay, I'll explain in a second when you look at your result how you interpret what it means. But let's just go through the process until we're done. So the next one. How about Rebecca? What's 3/2 times -2?
-3.
Yep, -3. Add 1 plus -3. -2 again. It doesn't always come out to 2 or -2, just this problem. And then 3/2 times -2, which is what we just did, is -3. And what's 3 plus -3? 0. Does anyone have a guess what the 0 is? That's your remainder. So the last row that we just created contains the coefficients of the quotient. So this is your quotient. This is your remainder. So you just have to count in the quotient box to see what's your highest exponent. So we have constant x squared. So my quotient is 2x squared minus 2x minus 2. That's my quotient. And my remainder is 0. So if I got a 0 for the remainder, what does that mean about x minus 3/2? It is a factor. And what does that specifically mean about the number 3/2? 3/2 is a 0. Exactly. Perfect. Yep. So the directions said show that 3/2 is a 0. Did that. And now write the original problem in factored form. 2x cubed minus 5x squared. Was it plus x minus 3? Minus x plus 3?
No, plus x plus 3.
Plus x plus 3. Thank you. Okay. So now to write that in factored form, well, we already know one factor. We just proved it. X x minus 3 halves. So that's x minus 3 halves times what would go in the parentheses next to it. Remember, so when you divide, like when we did yesterday, if I said, take the number 12 and factor it. So you start with a 3. Okay, we say, all right, 3 is a factor. And then you divide 12 by 3 and you get 4. What is 4 in that case? When you divide 12 by 3, 4 is called the what? The quotient. Okay? So the other factor is the quotient. It's what you get when you divide by the thing you already know is a factor. So 2x squared minus 2x minus 2. And now if you could factor that quadratic even further, you could try to do that as well. I think the only other thing you could do here if you wanted is you could factor a 2 out of that second part. So technically you could write it like this. And then what would clean it up a little bit is if you then distributed the 2 back to the other factor, and then you wouldn't have parentheses anymore. You wouldn't have fractions anymore. So you could write this as 2x minus 3 times x squared minus x minus 1. I don't really think there's anything else you could do with it. Okay, so there it is in factored form. Any questions on that one? Right, let's use synthetic division again to find the quotient and remainder when I do this problem. 3x to the 4th plus 7x cubed plus x minus 11. And I'm dividing by x plus 3. First, can someone tell me what number I would put on the outside of my bracket? Shauna? Yes. It's always the number that comes after the minus sign. So you've got to think of x plus 3 written that way. The only way to do it that way is like that. Minus 3. And then, Trevor, can you tell me my coefficients, the numbers I would write down?
30.
Yep.
7.
Yep.
1. Or negative
Careful. I'm sure. Can you help, Caleb?
0.
0. Do you see why you need the 0 now?
Yeah.
Yeah, because you're missing that x squared term. And then I agree with you. A 1 and then
11. Negative.
negative 11. Yep. The nice thing about synthetic division is I can put a box around this, and my work is never going to go outside that box. Versus long division, the way it kind of works is you just keep going like down and to the right. You need a lot of space. This you don't. Okay, bring down my 3. Negative 3 times 3. Yeah.
Negative 9.
Negative 9 plus 7.
Negative 2.
Negative 2. Negative 2 times negative 3 is 6. 0 and plus 6. Let's see. 6 times negative 3. And then 1 plus negative 18. What does that give me? Negative 17. Negative 17 times negative 3. 51 plus negative 11. 40. So, in this case, is x plus 3 a factor of my original numerator? No. So, it's not a factor, but they wanted us to write down the quotient and remainder. There's my quotient. 3x cubed minus 2x squared plus 6x minus 17. And the remainder is how much? 40. Right? So I like synthetic division when you can use it, just because it takes up a lot less space, and it is a lot faster.
Never mind.
Any questions on interpreting our result to figure out quotient and remainder? Okay. Another one that we can do the same approach. Show that 3 is not a root. Or show that 3 is not a 0. What would that be the same as doing? Showing that what is not a what. Yeah? That what's not a factor. Exactly. We're going to show that x minus 3 is not a factor. And how do you show that something is not a factor? Yep. Yeah, you do division, find the remainder, hope that it comes out to something that's not 0. So we're going to show that x minus 3 is not a factor using synthetic division. There's the number after the minus sign. 2, 5, negative 2, negative 3. Okay, Gracie, what's my first step?
Bring down the 2.
Bring down the 2. Sam, 3 times 2? 6. Juliana, 5 plus 6? 11. Tessa, 3 times 11? 33. And Rebecca, negative 2 plus 33? 31. 31 times 3 is 93. Plus negative 3, 90. There's your proof that 3 is not, or there's your proof that x minus 3 is not a factor, which means 3 is not a 0. Okay, this is not 0. That's why. Any question on that? So, we're going to look at a problem where it just says something like this. Find all rational zeros. You could also say find all real zeros, which means then you use the calculator to find the ones that aren't fractions. But the first one is just going to be find all rational zeros. And the strategy is you generally start with the rational root theorem. You use the graphing calculator to then narrow down your list of possibilities. And then from there, when you find one that works, divide through by it using synthetic division. Because if you can find at least one root that's going to work in this problem, and then you divide by it, you can turn this cubic into a quadratic. And we have a bunch of techniques for solving quadratics. You just have to find at least one rational root first. So if I give you a problem that doesn't have a rational root, you're going to be stuck. There's nothing you can do. So I have to give you at least a problem with one rational root. Okay, so let's make our list for P and Q. So P, all the factors of the constant. Tanya, what are all the factors of the constant here?
1, 2.
1 and 2. That's it. It's going to be a pretty short list. Plus or minus 1, plus or minus 2. What are all the factors of the leading coefficient? Yeah?
Plus or minus 1.
Just plus or minus 1. So we're not going to have a huge list this time. So I'm just going to put possible roots. Can somebody give me all the different possible roots with P in the top, Q in the bottom? Yep, Rebecca.
Plus or minus 1 and plus or minus 1/2. I mean, 2.
2. Yep. Plus or minus 1, plus or minus 2. That's it. So there's only 4 options you need to look at. So now we've got our rational root theorem done. We're going to graph it, and we're going to see which one of those look reasonable. Because I don't want to waste my time with synthetic division to just get a non-zero remainder. I want to figure out which one of those is going to work before I do synthetic division. All right. So we've got x cubed minus 3x plus minus 2. Now, I only need to look between -2 and 2, because that's where my answers are going to be. So I could probably just do zoom 6, but actually -8 to 8, that's more than I need, but that's fine, I can still see it. Okay, looking at that, what numbers seem reasonable? Yeah?
-1, +2.
I would say -1 and +2, and if they both work, then it doesn't matter which one you do. You're going to get the same answers in the end anyway. I'm going to check 2 just by tracing. Yes, 2 is a root. So now I'm going to divide through by x minus 2. So what I'm basically trying to do now is factor that. Okay, now off to the side, I'm going to put x cubed minus 3x minus 2 equals, and I already know it's going to factor with 2 as a root. I just need to figure out what goes there. And that's the quotient from synthetic division. So now we need to do that. So 2, 1. What do I want to be careful about when I write my exponent? Write my coefficients? Yep.
I'm missing
Which one am I missing?
the square.
Yep. 0 for the x squared, -3, -2. Okay, so bring down my 1. 2 times 1 is 2. Add, multiply, add, multiply, add. So now I know my other factor after I divide by x minus 2. What's going to go in parentheses next to it? What's my quotient? Yep.
X squared plus 2x plus 1.
X squared plus 2x plus 1. And I think we can factor that a little bit more. How does x squared plus 2x plus 1 factor? How would that factor? Yeah?
X plus 1 and x plus 1.
Perfect. X plus 1, x plus 1. So the whole key to this problem was we were able to find a rational root, divide through by it synthetically, and then factor it the rest of the way. So, what are my answers here for my roots? Yep.
2 and -1.
2 and -1. What's special about -1? It's a double root. Remember, we talked about double roots. Double roots kind of go up, touch the axis, and turn away. Had you picked -1 to start with, you would have had a different quotient, but it would have factored in a way that this would have been your 3 factors when you were done. You're still going to end up with the same factors. Questions on that? All right, let's try finding, same thing again. Find all rational zeros. Okay, let's start with our rational theorem. Factors of the constant this time is just plus or minus 1. How about factors of the leading coefficient? Leo?
Plus or minus 1, 2, 3, 6.
Perfect. So, my list of possibilities. How about, Caleb, can you give me my list of possible roots?
Plus or minus 1. Plus or minus 1/2.
Yep.
Plus or minus 1/3. Plus or minus 1/6.
Okay, so I only need to look between -1 and 1 when I graph this to narrow the list down. Okay. So let's type it in. 6x cubed minus 5x squared plus 3x minus 1. Again, I have negative 8 to 8. I think that's more than enough, but I should be able to get the idea. Okay, what seems reasonable there out of this list looking at that graph? I don't think plus or minus 1 really seems that reasonable. Yep, Gracie?
Plus or minus 1.
Yeah, I would say a half, but before I divide through by it, I'm going to check it. Yes, 1/2 is a root. Okay. So, let's divide through. I'm going to make a chart over here for the answers. 1/2. And actually, there's nothing else we need to do because if you look at the graph, it never crosses again. So it's a cubic. There has to be 3 answers. But what does that mean about the other 2? Yeah. They're imaginary. So actually, unless you wanted the imaginary one, that's all you need to do. If you wanted the imaginary, then you would divide through. You would get a quadratic, but when you solve the quadratic, you would get I in your answer. You get 2 imaginaries. Okay. Rationals are not imaginary. That's it for that one. All right, this one, okay, they want you to find all roots and then classify them as either rational or irrational. So this time they don't just want the ones that can be written as fractions, they also want the other ones. All right, so P, let's see, plus or minus 1, plus or minus 2. Q, plus or minus 1, plus or minus 3. So, possible roots this time. 1 over 1. 1 over 3, 2 over 1, and 2 over 3. Let's graph it and see which one works. Okay, so we've got 3x cubed minus 8x squared plus x plus 2. Again, I don't need to look past negative 2 to positive 2, but this should give me a good idea. Okay, what seems like a rational root in that case? Gracie?
Negative 1/3 and plus and positive 2.
Yeah, I would say negative 1/3 and positive 2/3. Let's try negative 1/3. No, not quite. Actually, negative 1/3 was a good candidate, but it's a little off. It's not quite a root. Let's try 2/3. Yes, 2/3 is a root. Okay, but again, I would have said negative 1/3 looked pretty good. So now we're going to divide through by 2/3. So I'm going to start a list of answers. 2/3. I mean, if you look at that number, it's somewhere bigger than 2. Are there any numbers in my rational root list that are bigger than 2? So what do you know about that other answer? It's going to be what?
Irrational.
It's going to be irrational. And so is this one. Because it's not negative 1/3, and there's nothing else in this list that's even close to that. So that other answer is also going to be irrational. Those are both going to be gotten with the quadratic formula. Okay? So we just have to figure out what my quadratic is. So we've got 3, negative 8, 1, 2. Okay, so bring down the 3. What's 2/3 times 3? Jane?
2.
2. And negative 8 plus 2 is negative 6. 2/3 times negative 6, so it's really 2 times negative 6 divided by 3. And what is that? Yep. -4. 1 plus -4 is -3. 2/3 times -3 is -2. Plus 2, 0. So we already knew we were going to get a remainder of 0. But now we have to look at that quadratic. Okay, any questions how we got that quadratic? Does anyone need me to go through the quadratic formula? I'll just tell you the answers you would get. So solve it with the quadratic formula and you're going to get 1 plus or minus square root 2. So the 3 roots in this problem are 2/3, 1 plus the square root of 2, and 1 minus the square root of 2. And it said to classify them. 2/3 is rational. Irrational. Okay. Any questions on that? Not going to worry too much about upper and lower bound. All right. So the homework, I got to just take off 1 or 2 problems. Don't worry about 31 and 32. But I think everything else should be okay. Yep. Okay, so on 183, 1, 2, 5, 6, 9, 10, 13, 14, 17, 18, 27. Okay, so we'll take a look at that tomorrow, and then tomorrow, that's it. Tomorrow's the last day of new material, and we'll have our test on 3.3 to 3.5 on Friday.